Consider the matrix M of the size 2 cross 2 is 1 1 1 0 belongs to M2R, means entries are coming from set of real number. Then the eighth power of M satisfies M raised to the power 8 to 1 0 equals to x y. So if anyhow we can find m raised to the power 8, then we can easily predict the values of x, value of x. So first try to find m square, which is 1 1 1 0, and this matrix multiply by itself give you m square. So m square is 2 1 1 1. Now m raised to the power 4 is multiplied to 1 1 1 with itself give you m raised to the power 4. So this value is 2 is 4 plus 1 5, 2 plus 1 3, this is 3 and 1, not 1 2. Now m raised to the power 8 is 5332 by 5332. 5 is 25 plus 3 equals to 34, and this value 53 is 15 plus 6 21. This value is again 21. 9 plus 4 9 plus 4 13. As it is given m raised to the power 8 1 0 give you x y. This implies that 34 21 21 13 multiply by column vector 1 0 give you 34, and this is 21, and this is same as xy, so value of x is 34. Option C is correct. The rank of the matrix of the size 4 cross 6 with the entries in real number is. To find rank of this matrix, we will apply elementary row operation on this. After applying elementary row operation, we have an equivalent matrix. So there is no change in first row 1 1 1 and 0 0. Second row is 0 minus 1 minus 1 1 1 0. Third row 0 1 0 1 0 1. Fourth row 0 0 0 1 1. This is our first equivalent matrix obtained by elementary row operation R2 minus R1. Now another equivalent matrix is whenever we will apply elementary row operation on R3, means R3 minus or R3 plus R2. This is our elementary row operation. So what we have, there is no change in first row 1 1 1 0 0 0. Second row 0 minus 1 minus 1 1 1 0. Third row 0 0 minus 1 2 0 1, and the fourth row is 0 0 1 0 1 1. So this is the matrix. Now another elementary row operation we are going to apply on R4. R4 minus R3. So what we have, first row is same, second row is same, third row is also same, and the fourth row is 0 0 0 2 1 2. So first entry of first row, second entry of second row, and third entry of third row is pivot element, and In fourth row, this is the pivot element. So we are getting 4 pivot elements. So rank of this matrix, call this matrix M, is 4. Option D is correct. We be a real vector space consisting of all polynomials in one variable with real coefficients and having degree at most 6. Together with the zero polynomial, in this vector space, zero polynomial is also there. Then which of the following is true? Option A, set given in option A is a subspace. If any set is form subspace, then it is necessary it contains a zero vector or zero element. So consider fx equals to 0. This is zero vector. Now we are checking that this function is in the set given in option A or not. So f half equals to 0, and 0 is a 0 belongs to q, but condition on set given in option A should not belongs to q. That's why option A is not subspace. Now for option B, if we consider a zero polynomial or zero function, then fx equals to 0. That's why f half equals to 0, but f half not equals to 1. That's why option B is not subspace. Now in option C, fx equals to 0. So value of f half equals to 0, and f1 is also 0. So these two values are same. That's why 0 vector is in. Now check option D is containing a 0 vector or not. So fx equals to 0, it means f prime x equals to 0, and f prime half is equals to 0, not equals to 1. That's why option D is not a subspace. Only option C is a subspace. You can check scaled property also. So correct option is C. Let G be a group of order 2022 and H and K with subgroup of G. H and K both are subgroup of G. Order of H is 337 and order of K is 674 respectively. If H union K is also a subgroup of G, union is subgroup of G if and only if either union is subset of H or H union K is a subgroup of H. As we know that order is given, and order of union is also a subgroup of G as it is given, and we know that order of subgroup divides order of group. So H union K, order of H union K will divide order of group, and this is 2022. As order of H is less than order of K, this implies that H union K is subset or subgroup of K. It means that if these are subset and these are subgroup, so order of H union K will same as order of K. So order of K will divide order of group, and order of K is 674 divide 2022. 2022 we can write 2022 after factorize by 2, 1011, and using 3, 3 is 9, 1 1, 3 is 9, and 3 7 ja 21. So 2022 can be written as 2 into 3 into 3 3 7. And if we multiply 3 3 7, we are getting 3 into 674, and obviously 674 divides this one. So it is perfect. Means order of union is 674. Now it is clear. So order of union cannot be 1011. Now option A is saying H is normal subgroup of H union K. To check normal, we try to find index H union K, index with H. This is equals to order of H union K divides order of H, and order of union is 674 divide 337, and we are getting 2. If index is 2, then we say that group is normal. So this is true, option C is true, and asking which one is false. So option B will be key for this problem. K is normal subgroup of H union K. You can find index also, index of K with union. So index is equals to order of H union K divides order of K, and this index is 1. If index is 1 or index is 2, then always normal. And we know that union of subgroup is equals to K. That's why any subset is normal to itself. Option D is also true. So key for this problem is option B. The radius of convergence of the power series, if series is given a n x raised to the power n, then radius of convergence r can be find using this expression limit n tends to infinity a n raised to the power 1 upon n. As power is given, then power 1 upon n means multiplicative inverse. So radius of convergence of this power series will be 1 upon limit n cube 4 raised to the power n raised to the power 1 upon 5n. So r equals to 1 upon limit n tends to infinity n raised to the power 1 upon n raised to the power 3 upon 5 upon 4 raised to the power 1 upon 5. This value is going to 1, that's why r equals to 4 raised to the power 1 upon 5, or fifth root of 4. Option B is correct. Xn and Yn be sequence of real number defined as you can see on my screen. Then which of the following is true? Xn is convergent, but Yn is not convergent. Xn is not convergent, but Yn is convergent. Means either x1 or y1 is convergent. Both are convergent, and the limit are equal or different. This type of options given in your question. So first, trying to find relation between xn and yn so that we can easily predict either x1 or yn is monotonic or bounded. As we know that xn plus 1, it is given xn plus yn divided by 2, and yn plus 1 equals to under root xn into yn. So this is algebraic mean AM, and this is geometric mean GM. And we know the relation between AM and GM. GM is always less than equals to AM. This implies that yn plus 1 is less than xn plus 1, and you can write yn less than equals to xn. Means all yn or terms of yn, sequence yn is always less than sequence xn. As xn plus 1 equals to xn plus yn divided by 2, and we know that yn is less than equals to xn. If you replace this yn, so what we have, xn plus xn, and this will be greater than equals to divided by 2, and this one equals to xn. From this we have xn plus 1 greater than equals to xn, means the sequence xn is monotonic decreasing, and yn plus 1 equals to under root xn into yn. So replace xn, try xn to find a relation between to find a nature of yn. As yn is less than equals to xn, if we replace xn by yn, so yn into yn, this will be less than this one. From this we have yn plus 1 greater than equals to yn, means increasing sequence. So xn is decreasing. Xn is decreasing. That's why x1 is greater than x2, greater than x3, and so on. Xn, and xn is greater than yn. This is greater than yn minus 1. This is greater than yn minus 2, and so on y1. From the questions as given, xn and yn have some point. Xn is 1 and yn is half. So other terms, either x1 and yn, both are between 1 and half. It means xn is bounded as well as yn is bounded, plus xn is monotonic and yn is also monotonic. So xn and yn both are convergent. Monotonic plus bounded implies convergent. This implies xn and yn both are convergent. Now try to find a relationship between limit of xn and yn. As xn plus 1 equals to xn plus yn divided by 2. Suppose limit of xn equals to L1 and limit of yn equals to L2. From this, L equals to L plus, L1 L2 divided by 2. From cross multiplication we have 2 times L1 equals to L1 plus L2. From this, L1 equals to L2. Both limit are same. Now try to find which one option is correct. Both xn and yn are convergent and limits are equal. Option D is correct. An and bn are two sequence and define two series using an and bn, and we have to tell about convergence of series an and bn. For this problem, if a sequence is convergent, if a series is convergent, then its limit of nth term, or sequence of partial sum is convergent. For this, we try to solve this problem. So first, summation an, if convergent, then limit of an equals to 0. This is the rule. And an is given to you, an equals to 3 raised to the power n plus 3, 5 raised to the power n minus 5. take 3 raised to the power n common from numerator. So 1 plus 3 upon 3 raised to the power n upon 5 raised to the power n, 1 minus 5 upon 5 raised to the power n. From this, you can find 3 upon 5 raised to the power n. This is a geometric progression with common ratio CR less than 1, and this is geometric series. So consider Vn. So Vn, limit of this expression is 1 not equals to 0. So An and Vn behave alike because Vn is convergent. This is convergent. That's why An is convergent. Now we have reached up to summation An is convergent. Now try to find out summation Bn is convergent or not. For this, Bn you can consider as 1 plus n square raised to the power 1 by 4. Now take n square common from denominator. So you can write Bn as 1 upon n square within bracket 1 plus 1 upon n square raised to the power 1 by 4. Also power 1 by 4 here. So what we have? We have 1 upon n raised to the power 1 by 2 within bracket 1 plus 1 upon n square raised to the power 1 by 4. Limit of this expression is finite. Finite and not equals to 0. That's why consider this is a Vn. So Vn and Bn behave alike, behave alike, and Vn is divergent. Vn is divergent because of p less than 1. That's why summation Bn divergent. Now try to find which one option is true. Summation An is convergent and Bn is divergent. Option C is correct. Consider the series as given summation 1 upon n raised to the power m 1 plus 1 upon n raised to the power p, where m and p are real numbers. Under which of the following condition does the above series converges? So if you consider this as a circular part, as a Vn, so this Vn will converge when m greater than equals m greater than 1. Apply P series test as you can observe summation 1 upon n raised to the power m. This is a series and this series converges when m greater than 1. And also 1 upon 1 plus 1 upon n raised to the power p, limit of this when n going to infinity is 1 not equals to 0, means finite and non-zero. That's why vn and this series vn and given series will converge or diverge together. They behave alike. That's why as vn is converging, so this series is also converging for m greater than 1. Option is correct. And in other options, as you can observe, m is not perfect for p series test. That's why b, c and d, all others are wrong.